Okay, section 3.4, part C, attributes of polynomial graphs and their zeros of multiplicity. So we've looked at the end behavior of graphs, and that tells us some information about what's going on with our graph, but let's also take a look at what's happening in the middle. So we need to look at the behavior of the graph near its zeros. And if you have a polynomial function p of x with the factors, so in factored form, and those factors are x minus c to the m, and m is the degree of the factor, and c is a real number, if the degree of the factor is odd, then the graph is going to cross through the x-axis. If the degree of the factor is even, then the graph will bounce off. Oops. It's going to bounce off the x-axis, touching at just one point. So in each of these cases, it's going to be more compressed at that zero, which means flatter, near that zero, which is our c value, for larger values of m. So let's just take a quick look at that. Here we have a function f of x is equal to x plus 1 squared. So on our graph, that's going to give us our 0, our c value, to be -1. And our other factor is x minus 2, which gives us our c value of +2. Whoops, up here. So those are the zeros of our function. And then if we look at our multiplicity on our c value of -1, m is equal to 2. So this is behaving like a parabola. And the other one, our degree is 1. So m is 1. You can see that this is behaving like a line. So here we're bouncing off. And then here we're behaving like a line. It goes through the x-axis. Okay. Now, in the next graphs, we have the same factors, x plus 1 and x minus 2, but our degrees have changed, and that should make our graph look flatter. So again, we have here c is equal to -1, and here we have c is equal to 2, but let's zoom in on those. So our degree has now gone up to 4. Well, you can see that the parabola is much flatter here than it would be if it's a regular parabola. And then we have our degree here has changed from a 1 to a 3, and now this is behaving like a cubic. Again, it's much flatter at that 0 value. So even though the factors are the same, the degree is going to make the graph look a little bit different. So let's take a look at a graph and see what information we can gather about that graph. So state whether the degree of this function is odd or even. Well, to do that, we need to look at our end behavior. So here on the left, it's going down, and on the right, it's going up. So they're going in opposite directions, and in that case, we know that our degree is odd. Question B, use the graph to name the zeros of the function, then state whether their multiplicity is odd or even. Well, let's take a look at our zeros. Here's our first one. At x is equal to -2. And you can tell at that point it bounces off. So that's going to tell us that we have an even multiplicity, and that m value is going to have to be greater than or equal to 2. It looks like a parabola, degree of 2, but we can't really tell if it's flat or not. So it may be 4, maybe 6, but most likely it's going to be 2. Okay, let's take a look at the next 0, which is here. And that's the x value of -1. And again, this bounces off, which means our multiplicity is even. And again, our m value has to be greater than or equal to 2. We're not really sure, but it has to be at least 2. And let's take a look at our last 0, which is here, which is x is equal to positive 1. And this time it goes through our x-axis. And it's also compressed because it's not going through like a line, it's going through like a possible cubic function. So based on that information, we know that this is odd and that the m value is greater than or equal to 3. So it could be 3, could be 5. We know it's not 1. So let's figure out what our minimum degree is. So let's try to write out the factors for this function. So f of x is equal to, well, we're not sure what the a value is, so we'll just list it as a. And for our first 0, we have x equals negative 2. That comes from the factor x plus 2. And we said that it has to be 2 at least. So that's coming from our information here. So this value where it bounces off, we said it had to be greater than or equal to 2. So we're going to list that there as our multiplicity. Okay. Our next factor coming from the 0 of negative 1 is x plus 1. And again, we said that that had to have a multiplicity of 2, at least. Could be more, but right now we just know that it's 2. And then our last factor is x minus 1. And we know that that one has to be at least 3. Write a 3 in there. So based on that, add them all up. And our minimum possible degree is 7, which we look back at A, we said our degree had to be odd. 7's odd, so we're at least on the right track. It may be higher than that, but is at least 7. And then if we state the domain and the range, x is an element of the interval of all real numbers, so negative infinity to infinity. And then for our range, y is an element, again, of all real numbers, negative infinity to infinity. The next example we're going to work on in class, so we'll just skip over that for right now. Okay, so last time we were looking at graphs and figuring out some information, but what if we have the polynomial in factored form? Well, all we need to do is add up all the exponents of our linear factors. And again, that's linear factors. But what if our factors are quadratic? What if they weren't factorable? Well, then we just need to add 2 because quadratics are of the second degree. So we're going to add 2 for anything that's not factorable, or sometimes we say that that's prime. And we'll look at a couple examples here. Before we do that, we also need to repeat how to find the y-intercept. We substitute in 0 for x, and we're going to solve for f of 0 equals y. So we're solving for our y. Okay, so in our first example, state the degree. So let's take a look at all of our factored form of our zeros. This is a linear factor because it's of degree 1. And its multiplicity is 5. Next factor, again, is linear because the x is to the first power. Whoops, I want to do that. And its degree is 2. And then our last factor is also degree 1, and its multiplicity is 1. So if we just add all of those up, 5 plus 2 plus 1 gives us 8, which is even. It's going to help us with part B. Describe the end behavior. Well, we know the degree is 8, which is even. Our leading coefficient is 1, which is positive. So if we look back at our end behavior, if we have an even degree and a positive leading coefficient, that means it's up on the left and the right. Okay, let's calculate our y-intercept. So we're going to find g of 0. So just substitute in 0, 0 minus 3 to the 5th power, times 0 plus 4 to the 2nd power, times 0 minus 1. So negative 3 to the 5th power is negative 243, times 4 squared, which is 16, times negative 1. If we multiply all those together, we end up with 3,888. So there's our y-intercept. Now, that's not something that we want to graph, but that's where our y-intercept would be. In your homework, you're going to find ones that are more easy to plot. They're going to be much smaller numbers. Let's take a look at our second example, q of x. Again, let's take a look at the degree of each one of our factors. And this first factor is linear. Its degree is 3. Second factor is also linear. Its degree is 4. But our last factor is quadratic. So we need to account for the 2 inside the parentheses. Even though the degree of that factor outside is 1, it's really quadratic. So let's add those all up. We have 3 plus 4 plus 2, which gives us 9. And 9 is odd. It's going to help us with part B, describe the end behavior. Well, if you look, our leading coefficient is negative. And then with a odd degree, that tells us that we are up on the left and down on the right. And then part C, we're going to find q of 0. So that equals the opposite of 0 plus 5 to the 3rd times 0 plus 6 to the 4th times 0 squared plus 3 times 0 minus 7. So you get the opposite of 5 to the 3rd power, which is 125, times 6 to the 4th, which is 1,296, times negative 7, and when we multiply that all together, we get 1,134,000, and that is our y-intercept. Again, not something that we're going to want to plot by hand, but that's what it calculates to be. Okay, we're done.